Good morning. This morning we're building balance leads to balance charge all of the cells that we have. So I'll just run through this fairly quick and show you how I put together a balance lead that works pretty well for us. I've cut 9 pieces of 20 AWG silicone wire. So those will be my balance leads because I need to extend these wires off of these plugs a wee bit. So here we go. I think I'll put terminals on first. So I'm using, spade terminals for these. So I like to fold these ends over so that the terminal crimp has a bit more solid of a grip on the wire. I find if I don't do that, about 1 in 5 or 6 will just pull right off of there. All right, now we're at the heat shrinking station. I like these little terminals with the sleeves on them. They have a heat shrink lined with glue, so when you shrink them, they glue themselves onto the wire and the terminal and kind of provide some strain relief. I've been real happy with them. Okay, when I'm done with this, I'll strip the other ends of these wires and then hook them up to that, I think it's called a JST connector. Not totally sure on that, but I have some inline shrinky dinks with low temperature melt solder in them. So I'll connect those wires up to these. Okay, these are the little shrinky dinks that I was talking about. It's an inline wire connector. So there's a little ring of low temperature melt solder right here, and then shrink tube lined with glue. So you just splice your wires. Well, actually you slide that onto the wire first. Make sure and always do that first. But slide that onto the wire, twist the wires together, and then slide that over the twist so that the solder is right over the 2 connected wires. And then when you melt it on the heat gun, it'll infuse that joint with solder and then glue the 2 pieces of wire insulation together with this shrink glue tube stuff. So I like to slip one on all these wires first, then strip them, and then connect them up to the, oh, what is this? I think it's a JST connector. It's used for hobby charging. So yeah, I'll just thread all these and then I'll be back and show you how they shrink. Okay, so make sure and slide that sleeve so the solder ring just covers the wire joint. And then you can melt the heck out of it. So the sleeve will start shrinking first, and then you'll see the solder turn to liquid and soak into the wire. And there it goes right there, soaking into the wire. Boop. And then I just move it back and forth a little bit and get the ends of the tube shrunk. That one's done. So we'll do, that was the nag. Let's do cell number 2 on here. So I just twist the wires together, and then I bend it over in the middle, and then roll it real good between my fingers, and that seems to make a nice strong joint. So then we slide the sleeve up. Oh, tangled wires. How I love thee. There we go. Okay, wait. Right there. Boop, there goes the solder. And just shrink the ends down a little bit. Oh, yeah. There's number 2. It's getting hot. There's number 3. So, again, I just even up the ends of the wires, twist them together good. Crimp it in the middle, and then kind of roll it in between my fingers just to integrate the wires with each other real well. So yeah, I'll get all these rest of these done, and then I'll be back. All right, now I want to put labels on these terminals so that I'm less likely to mix them up in the future. So this is the main negative, and I just printed out some labels on my label maker, so I'm going to put neg on there. There's neg. White is cell 1. Etc. on down the line. Okay, so I have 64 cells that I need to balance, and it was going to take 44 days to balance them in the normal traditional way by paralleling all the cells and then hooking up a power supply at 3.65 volts. So I needed a quicker way. I have 3 of the ISDT hobby chargers. They are a balance charger. What they do is they bulk charge up to 8S pack until the first cell reaches your configured voltage. So I've got it set to charge all the cells to 3.6 volts. So when the first cell in each of these 8S packs reaches 3.6 volts, it cuts the charging amps way down, and then it just brings all the rest of the cells up to 3.6 volts to match the first one that reaches 3.6, whichever one that happens to be. So I have two 8S packs, 24 volt nominal configured, and I've got an ISDT hobby charger on each one. And so this one is charging at 10 amps currently, and you can see that, oh, I don't know, there's a very small difference in the cell voltages right now, and it's bringing them all up bulk at 9 amps, charging through these clamps. And then once, you know, the first cell reaches 3.6 volts, it'll cut the charging on these terminals and then just charge through the balance wires slowly to bring the rest of the cells up to 3.6. So this rig here is running off one of these Meanwell power supplies. It's a 27 volt power supply. These can take up to 30 volts input, and then they'll output whatever voltage you need. And since I have kind of limited off-grid power now, I've got this one charging bulk at 4 amps. Once this one reaches the end of the bulk charging cycle, I'll bring the amps up on this one too, so it'll charge quicker. But this one's just powered by a regular old power supply I got off Amazon. And it's pulling 106 watts right now. Almost 4 amps. I've got that one set up to 27.7 volts. I could actually run that up to 30 volts if I wanted to, but it's working just fine, so good to go. I'm gonna set up a third 8S pack. So I'm just gonna kind of do these in turn, you know. I'll just I've got 2 going now. I'll have 3 going by the end of this video, and then I'll have 3 more 8S packs that I'll need to charge over a few days. So I should, you know, complete this process in probably 7 to 10 days as opposed to 44 days. So that seems like a good advantage to doing it this way. So what I need to do now is take another 8 cells off of this paralleled pack and configure them as 8S 24 volt nominal, and put this third hobby charger here on them with this new power supply that I've got here. So that's what I'm gonna do. So yeah, I'll be back as soon as I'm ready to do that operation. All right, now I need to alternate the terminals on these 8 cells so that I can connect them in series. All right, I've got this cell group set to alternate minus, plus, minus, plus, minus, plus, minus, plus. White, black, white, black, white, black, white, black. Just want to double check that. So now I can connect these in series and hook up balance lead, check the balance lead, make sure it's wired properly, and then hook it up to the hobby charger and balance charge the cells. So I'm just going to make a little terminal here. So that's negative. And positive. So now I need to arrange the bus bars to connect these in series. So negative to positive. So there we go. That's the configuration for a series 24 volt nominal battery bank. So I'll screw this together and then I'll bring you back and show you the balance leads and how I test them. All right, I have my terminal screws in place, my bus bars placed. So I'm going to start hooking up the balance lead so that the balance charger can do its thing. So main negative goes here, obviously. Cell 1 positive here. Cell 2 positive here. And so on. And cell 8 positive here. So now that I have all these connections cinched down good, I'm going to test the series connection and the balance lead to make sure it's hooked up properly. So and we've got 26.41 volts there. So on these JST connectors, there's exposed contact metal here. So if I just test here, I can make sure that I've got the proper sequence and I've got the balance leads wired properly. Now, in theory, this should be the negative here. So on these first two, you want to be careful not to touch the probes because it'll short and you'll do some surprise welding. But cell 1 should be around, 3 point whatever volts. And that's cell 1 here, 3.3. And then each successive contact should go up by 3 volts and change. So this one is 6.6, that's good. 9.9. 13.21, that's good. 16. 19, 23, and 26. So I know I have that wired properly. And then before I hook it up to the $90 hobby charger, I'm going to hook it up to one of these $20 cell checkers and balancers. So let's see, I got to get the negative configuration proper. Because I'd be much less sad if I lose this than if I lose that. And I have lost a few of these. That's why I learned to check with the multimeter first before hooking these up. So, yeah, that looks all good. 5 millivolts delta. 40% charge. So yeah, that's good to go. All right, so here's my hobby charger that comes into play next. This is a T8 capable of 1,000 watts maximum charge. It's got a little mark here for negative, and I want to make sure the black negative wire lines up when I connect that. Okay, so that's a good solid connection there. So this is the main bulk output for the hobby charger, and it'll charge the pack as a 24 volt nominal until, again, the first cell in the pack reaches 3.6 volts. Then it'll cut the charging way back and just concentrate on the individual cells and bring them all up to that same 3.6 level. So let me make sure I get the polarity proper here. Positive. There'll probably be a little spark. No, not this time. Negative. Okay, so now I bring in the power supply. And once I hook these Anderson connectors up properly, it should power up and allow me to configure for charging. All right, there we go. Got the cell voltages correct. So I just want to make sure the configuration is proper. So battery type is lithium ion. So I want to charge to 3.6 volts per cell. Once they are all balanced charged to 3.6, I'll break the pack down, parallel them again, and do the final balance charge direct from the power supply at 3.65 volts on the power supply. And you know, I did that this morning on my 12 volt pack, and it took maybe 2 or 3 hours to just do that final top up and balance. So cell count is correct. Current, I think I'll drop that to 4 amps because I'm kind of limited here into how much power I have available from our off-grid system. Four amps. Task charge. Start. All right. 5, 4, 3, 2, 1. Blast off! All right, there she goes. You can see the amps climbing. So it's charging at 4 amps. And yeah, that'll go for a couple days, and then it'll balance the cells, and then we'll be good to go. So that's it. Dark Star on the Metagrid signing off again.